For today's video, we're gonna focus on another way to solve for the derivative of a function, and that is the product rule. We can use this whenever a function is multiplied by another function. Say for example, f of x equals 2x squared plus 4 times 3x minus 1. Notice that we have two smaller functions, this one and this one. Now, let's take a look at the formal definition of the product rule. The derivative of u times v is equal to u times v prime plus u prime times v. Here, v prime represents the derivative of v, and u prime represents the derivative of u. Let's use this formula to find the derivative of this function. First, we need to assume values for u and v. Now u is 2x squared plus 4. We have 2x squared plus 4. While v is 3x minus 1. We have 3x minus 1. What you want to do next is to derive these functions. U prime, which is the derivative of u, is equal to 2 times 2 is 4 times x to the power 2 minus 1 is 1. Plus, the derivative of 4 is 0, or we can simply write this as 4x. V prime will be the derivative of 3x is 3, minus the derivative of 1 is 0. All we need to do is to plug in these values to the formula. The derivative f prime of x will be u, which is 2x squared plus 4, times v prime, which is 3, plus u prime, which is 4x, times v, which is 3x minus 1. Let's distribute 3. We have 2x squared times 3 is 6x squared, plus 4 times 3 is 12. Let's distribute 4x in here. We have 4x times 3x is positive 12x squared. 4x times negative 1 is negative 4x. Now let's combine like terms. 6x squared plus 12x squared will add up to 18x squared minus 4x plus 12. This is the answer. 18x squared minus 4x plus 12. Let's have another example. What is the derivative of x cubed sine x? Go ahead and try this one. Feel free to pause the video, and once you're done, you can unpause the video and check your answer. In this case, x cubed is u, and sine x is v. U is equal to x cubed, and v is equal to sine x. Let's differentiate these two functions. U prime is equal to the derivative of x cubed is 3x squared, and v prime is equal to the derivative of sine x is cosine x. Let's plug in these functions into the formula. U is x cubed times v prime is cosine x, plus u prime is 3x squared times v is sine x. We can factor out x squared from these terms. We have x squared times x cubed divided by x squared is x times cosine x plus 3x squared divided by x squared is 3 times sine x. Now, x squared times x cosine x plus 3 sine x is the answer. How can we apply the product rule to find the derivative of 3 cosine x tangent x? For this problem, we must be familiar with trigonometric identities. To start off, we need to separate these expressions into two. Here, 3 cosine x will be u, and tangent x will be v. U is equal to 3 cosine x, and v is equal to tangent x. Let's derive these two functions. U prime is equal to 3 times the derivative of cosine x is negative sine x. We get negative 3 sine x. For this one, the derivative of tangent x is v prime is equal to secant squared x. Let's substitute these values into the formula. We have u is 3 cosine x times v prime is secant squared x plus u prime is negative 3 sine x times v, which is tangent x. One important trigonometric identity is that secant x is equal to 1 divided by cosine x. Thus, we can write secant squared x as 1 divided by cosine x squared. We have 3 cosine x times 1 divided by cosine x squared minus 3 tangent x sine x. Cosine x divided by cosine x is 1. The remaining value on top will be 3. On the bottom is cosine x minus 3 tangent x sine x. We know that secant x is equal to 1 divided by cosine x, or 1 divided by cosine x will be equal to secant x. Thus, we can write the answer as 3 secant x minus 3 tangent x sine x. Now, this is the answer. You can also factor out the constant 3 if you need to. Both answers are correct and valid. Let's move on to the next example. How about the derivative of x squared times e to the power x? Go ahead and try to answer this question. Here, x squared will be u, and e to the power x will be v. The derivative will be the first part, which is x squared, times the derivative of the second part. The derivative of e to the power x will remain e to the power x plus u prime. The derivative of x squared is 2x times v, which is e to the power x. Notice the variables in this expression. At this point, we can factor. Here we have x squared times e to the power x. And here we have 2x times e to the power x. So they have x times e to the power x in common. X squared divided by x is x. E to the power x divided by e to the power x is 1, leaving behind x. 2x divided by x is 2. E to the power x divided by e to the power x is 1, leaving behind 2. This is the answer in factored form. X times e to the power x times x plus 2. That's how you use the product rule when finding the derivative of a function. How can we apply the product rule to find the derivative with respect to x of sin x divided by x? Notice that we can move x on top, but the exponent will become negative. Instead of dividing sin x with x, we can multiply it with x to the power negative 1. It becomes the derivative with respect to x of sin x times x to the power negative 1. In this case, u will be sin x and v will be x to the power negative 1. The derivative of sin x will be u prime is equal to cosine x. The derivative of x to the power negative 1 will be v prime is equal to negative 1 times x to the power negative 1 minus 1, which is equal to negative x to the power negative 2. Let's plug in these functions into the formula. We have u, which is sin x, times v prime, which is negative x to the power negative 2, plus u prime is cosine x times v, which is x to the power negative 1. We need to get rid of the negative exponents here and here by moving this on the bottom. We get negative sin x divided by x squared plus cosine x divided by x. And this is the final answer. Now, what if the function involves not just multiplying two functions but three functions? The derive formula in finding the derivative will be the derivative with respect to x of f times g times h is equal to f times g times h prime plus f times g prime times h plus f prime times g times h. Here, the three functions are f, g, and h, while their derivatives are f prime, g prime, and h prime. What we're gonna do is to prove this formula by using the product rule. To start off, we need to separate f, g, h into 2. Let's assume that f times g is u and h is v. The next process is to derive u and v. Notice that f is multiplied with g. Thus, we can use another product rule. U prime will be the first part f times the derivative of the second part g prime plus the derivative of the first part f prime times the second part g. On the other hand, v prime is equal to h prime. Let's go ahead and plug in these functions to the formula. The derivative will be u, which is fg, times v prime, which is h prime, plus u prime, which is f times g prime plus f prime times g, times v, which is h. Let's simplify this further. We have f g h prime plus f g prime times h is f g prime h. F prime g times h is f prime gh. This will be the formula that we're gonna use whenever there are three functions involved. The first thing you need to do is to identify f, g, and h. Then derive these functions to get f prime, g prime, and h prime individually and plug in the values into this formula. That's it. I hope this video gives you a better idea on how to use the product rule. If you found this helpful, please click like on my video or subscribe to my channel. Also, comment down below if you have any questions or recommendation for the next video.